Hey guys, it's Miss Miller. Let's look at a couple of practice problems with displacement and velocity. So this first example, it says Heather and Matthew walk with an average velocity of 0.98 meters per second eastward. If it takes them 34 minutes to walk to the store, what is their displacement? So we have a couple things that we're going to look at. First of all, we have 0.98 meters per second. That is a velocity. That is a unit for distance over a unit time. So I know an average velocity, and also it tells me an average velocity, is 0.98 meters per second. When you're solving these problems, it's always best to go and actually write what you know first, just like you would in a math word problem. That's basically what this is. If it takes them 34 minutes, so it gives us a time of 34 minutes. Now I can already see that I have a problem here, because here my unit for time is seconds, here my unit for time is minutes, and everything has to match up when you're solving a problem. So I'm going to go ahead and convert 34 minutes into seconds. Now I chose to do that because converting meters to seconds to meters per minute doesn't make sense, since meters per second is already in the SI unit for velocity. So we know in 1 minute there are 60 seconds. So 34 times 60 is 2040 seconds. Now it says what is their displacement. So we know that delta x equals velocity times time. I know that because velocity equals delta x divided by time. So if I multiply both sides by t, then I'm left with this equation. So displacement, which is delta x, equals 0.98 meters per second. I'll go ahead and write my units here, times 2040 seconds. Now if we do a little dimensional analysis here, we see that seconds here will cancel out with seconds here, and we should be left with the SI unit meters. So 0.98 times 2040, 1999.2. If you notice, our problem only gives us 2 digits here, 2 digits here. I'm going to go ahead and just round that to 2,000 meters. It's approximately 2,000 meters. But if you leave the answer as 1,999.2 meters, that'll be fine too. In the grand scheme of things, it's about 2,000 meters. We also need to add a direction to this. So since they're moving to the east, and we added the direction because it specified displacement where direction matters. Alright, you could also say 2 kilometers instead of 2,000 meters. Okay, a little bit of a longer problem. It actually has 2 parts, but it shouldn't be too big of a deal. So yeah, bus travels 280 kilometers south along a straight path with an average velocity of 88 kilometers per hour to the south. Okay, notice when it's talking about displacement, it indicates the direction south, and when it talks about velocity, it indicates the direction south. It stops for 24 minutes, and then it travels, more to the south with a different velocity. How long does the trip last? So I'm just going to draw a little bit of a picture. For this first section, it's 280 kilometers, and we know we're moving south, and my velocity equals 88 kilometers per hour. And then we're going to stop. I'm going to put a note right here. We stop for some time, 24 minutes. Okay, and then I continue moving south for another distance of 210 kilometers with an average velocity of 75 kilometers per hour. So it's asking me how long. That indicates we're looking for time. I've written down everything I know, and I've even included a little picture here. So I need to use what I know in order to find a time here, a time here, and then I'll add that to this 24 minutes to get a total time for the trip. Since I have velocity and displacement, I'm going to go ahead and use this equation. Velocity equals delta x over t, delta x being my displacement, velocity being, or v being my velocity. Now if I solve this for t, I multiply t by both sides, and then I divide by v, so delta x over my velocity will give me my time for each section. So I'm going to do that. T1 is going to equal 280 over 88 kilometers per hour. Let's see, 280 kilometers per hour. And we'll get an answer in hours because these kilometers will cancel. So 280 divided by 88 is 3.2 hours. Alright, and T2, we have 210 kilometers over 75 kilometers per hour. Kilometers will cancel. Oh, I'm sorry, you can't see that. And that equals 210 divided by 75 equals 2.8 hours. Now, I have my three times, 24 minutes, 2.8 hours, and 3.2 hours. The only thing I need to do for part A is convert this 24 minutes into hours. So we know 24 minutes times 60 minutes in 1 hour. Looks like I divide by 60 in order to get my time in hours. So I'm going to do 24 divided by 60, and that's 0.4 hours. So now I can do T1 plus 0.4 hours plus T2 will equal my total time. So 3.2 hours plus 0.4 hours plus 2.8 hours equals, let's see, this is 6.4 hours. Alright, and that is the answer to part A. Now, if we go back and look at part B says, okay, well, what is the average velocity for the whole trip? So now we're looking for average velocity. Well, we know that velocity equals our displacement over time. Now we have a total time. We can add up 280 and 210 to get our total displacement, divide by 6.4 hours, which is the total trip time, and we'll have our total velocity. So 280 and 210 is 490 kilometers over 6.4 hours. You get 76.5 or 77 kilometers per hour. Now guys, I'm not going to dock you for the number of decimal places. Just please don't give me calculator vomit. And by calculator vomit, I mean if your problem's only giving you 1 and 2 digits per number, then don't give me a calculator answer where it's rounding to like 8 decimal places. Okay? Just, I want to say use common sense, but what I mean by common sense is if all of my numbers in the problem have like, they've rounded their values to the nearest hundredth, then it's a pretty good gauge for you to round your answers to the nearest hundredth or even 10th place. But don't be giving me 8 decimal places, 9 decimal places. Even 5 is pushing it unless you're dealing with really small, very precise numbers in your problem. But I won't dock you for that. unless it's just ridiculous. So your answer there is 77 kilometers per hour. Now we want to make sure that we include a direction. We go back to our problem. They were moving south. So to complete our answer, we're going to say south. Alright guys, hope this helps. Go ahead and work on your displacement and average velocity problems.